Drawing regression line or trend line in both Excel and SPSS. Drawing a regression line or trend line in Excel. Here in this Excel sheet, I had inserted data for 51 students, and I had split the data into two variables or two set of data. The first one is labeled as number of hours, and the second variable is the mark or the score in an exam. So for the first student, he had studied for 15 hours and he achieved a 95% mark in an exam for a specific subject like science. Student number 46 had studied for 6 hours and he achieved a 75% mark. The data also labeled as X and Y. To draw a regression line, it is important to determine which data will be added into the X-axis and which data will be on the Y-axis. So the data for the X-axis is called the predictor, and the data for the Y-axis is called the outcome. And to draw a regression line, first of all, we have to draw a scatter plot. The objective of the scatter plot is to look at the relationship or the correlation between the two variables, the predictor and the outcome, and then determine what type of relationship. Is it a linear relationship? Is it a positive or a negative? i.e., when there is an increase in one data, there is an increase in the other one, and when one of the data is decreased, the other one is decreased. This is what it means by positive or a negative relationship. Once the scatter plot is drawn and the relationship is determined, then the software will try to draw a regression line or a trend line that best fit the data. Once this trend line or regression line is drawn, it is possible to generate a regression equation. And the significance of this regression formula, it can be used to predict an outcome from certain input value, i.e., the outcome or the mark for specific individual or the percentage for specific individual can be predicted based on the number of hours he or she studied. So that is the overall objective of drawing a regression line. And the way to do that, first of all, select the data to generate a scatter plot. Then in the menu here, click on insert, and then select the chart, and then select the scatter plot. Excel will generate automatically a plot that represent the relationship between the value on the x-axis and the value on the y-axis. I'm going to do a few editing here. If I click on the add charts elements here, I could add a title for the x-axis and a title for the y-axis. And I'm going to change the title of the plot into H, which is hours versus the marks for each individual, and on the x-axis is the number of hours each individual student had studied for. So we label that hours, and for the y-axis I'm going to label that as marks for the scores achieved by each individual participant. And I'm going also, if we click on the plot here or the graph and click on the plus sign, I'm going to get rid of the grid line, and I'm going to do also further editing. As we can see here that the lowest mark by the students in this data or group of data is 40. So I'm going to click on the data here and then select the data here, and then I'm going to click on the axis options, and I'm going to select the minimum value to be 35. And if I click on the 35, the data will be, the score will be start, the y-axis will be from 35 as shown here. And if I want to insert a regression line or a trend line, just click on, there are several ways to do it, either from the chart and then trend line, or from this plus sign and then click on the trend line, and automatically a line is inserted. And I could also scroll down further and look for more options, and then as we have selected here the linear line, I'm going to tick the box for the R squared value and the box for the displaying the regression equation on the chart. And as we can see here, a formula is generated or an equation, and I'm going to increase the font size a little bit more as shown here. And I'm also going to change the color of the regression line by double clicking on it and then select the color, and I'm going to make it red colored, and I'm going to change the line into a straight line rather than dashed line, and then increase the thickness of the line. So now from this graph, it's clearly shown that the data on the x-axis is the number of hours each individual student has studied for, and the y-axis is the percentage or the mark from 0 to 100. And as you can see from the scatter plot that there is a positive linear relationship between the number of hours studied and the total score or mark. Excel has already generated the regression equation. As shown here, I have placed the representation of this equation. Y stands for the outcome, and P notes is for the intercept, and the intercept, which is in this case 51.035, the intercept is the value of the y when the x equal to 0. And the P1 represent the gradient or the slope multiplied by x. So that's what the regression formula here represent. We could also calculate each part of this equation separately, and the way to do that, first to calculate the correlation between the predictor and the outcome. To do that, click insert equal sign and then type correlation. Click on the correlation, and it says insert the array number 1 and array number 2, and in this case I'm going to insert the predictor first and then separate that by a comma, and then insert the second set of data, which is the outcome. And if I click enter, a value of 0.85 is generated, so reducing the decimal point. To calculate the R square, what does this value mean? It means that the relationship between the predictor and the outcome is linear and it is positive. To calculate the R square, insert the equal sign, then insert the R value here, select the R value, insert the multiplication sign, and then insert again the R value here. Click enter. A value of 0.721 is generated, which is equivalent to the R2 calculated by the software here. What does this mean? This value means that 72% of the variance in the outcome can be explained by the predictor. To calculate the slope again, insert the equal sign, type slope, and there is a function or a command in Excel called slope. And to work out the slope, first insert the data as it's shown here in this order. The data for the y-axis, have to be careful here. First the y-axis, comma, then the data for the x-axis, and then hit the enter key. A value of 3.59. We're going to reduce this into 2 decimal point, which is equivalent to this one value here in this equation. To calculate the intercept, again type intercept. A command is available in Excel, and again we need to add the data as shown here, data for the y-axis separated by comma, and then select the data for the x-axis and hit the enter key. Going to reduce the decimal into 51.035 as it's shown in this equation. So now we have the value for the slope, the value for the intercept. We have the equation here, the regression equation. It is possible to use the regression equation to calculate the outcome for any given value for the hours studied by students. So let's say if a student has studied for 6 hours, what will be the predicted mark or predicted outcome from this study, i.e. what will he achieve in the exam? So we'll use the equation here by inserting the equal sign, and then we will use the 3.6, which is the slope, multiplied by 6 hours. We'll add to that the intercept value, which is 51. And if I click on enter, the student would have, if he studied for 6 hours for the exam, he would have achieved a 73% mark based on the data we have here, based on the regression line drawn here, and based on the equation given here. So this is the benefit and the useful application of the trend line or regression line to work out the regression formula or equation and then to predict an outcome. If a student has studied for 12 hours, we could also change that from 6 to 12 and we get a mark of 94%. So here we have a regression model based on a regression line with a regression formula, and from that model it is possible to predict the outcome. In this case, the mark that could be achieved by the student. This is the way to draw a regression line in Excel and use that regression line to predict an outcome. Drawing regression line or trend line in SPSS. Here in Data view in SPSS, I had inserted a data for 51 students. The data is in two columns or two variables. The first one is labeled as hours and the second one is labeled as mark or score. So for variable number 1, represent the number of hours each individual student has studied for the exam, and the mark is the percentage of the mark achieved by each individual student, and it is measured from 100%. So for student number 1, he studied for 15 hours for a specific exam and he scored 95% in the exam. And for student number 34, he studied for 5 hours and he achieved a 45% mark in the exam. And to draw a regression line for these data, first we have to check whether these variables are normally distributed or not, and I had already did the analysis and the test, and I found that both are normally distributed. For further information, there are more videos or video clips on the channel to watch and to download on how to check the normality of your data. It's important also, if we want to draw a regression line, to make sure that we have a data for x-axis and y-axis. The data on the x-axis is usually the predictor, and the data on the y-axis are the outcome. That's the outcome here will be the mark, and the predictor will be the number of hours. So the number of hours a student study for an exam will predict the outcome. To draw the regression line for this data, first of all we need to draw a scatter plot. The scatter plot will determine the relationship or the correlation between this set of data, the strength of the relationship, whether it's linear or not, and whether the relationship is positive or negative. Positive meaning an increasing relationship. If there is an increase in the hours, then the mark will increase, and a negative relationship mean that there is a decreasing relationship. So the first step is to draw the scatter plot. Then from the scatter plot, the software will try to fit the best regression line to the data, and then from the regression line a regression formula or equation is generated. Based on that equation, it is possible to predict the outcome, i.e. the mark for any individual or participant or a student based on the input. So whatever number of hours it is he or she studied, the outcome for the exam based on the data and based on the drawn regression line, it will be possible to predict the result for the exam. So to do the first step in drawing a regression line, first of all, draw a scatter plot. Click on graphs, scroll down to legacy, scroll down to scatter plot, select simple scatter, and then click define. It's very important here in this window to choose the variable carefully. the predictor here is the number of hours each student has studied for, and the marks are the outcome, that is the percentage for the exam achieved by a student, and it will go into the y-axis, which is the outcome. If we click on titles, also I could make a title for the plot or chart that will be generated. So we'll call it hours versus mark. Click on continue, then click on OK. A chart is generated, scattered plot that shows the relationship between the hours, number of hours, and the percentage or the mark. As we can see here, there is a positive and linear relationship between those two variables. I'm going to do a few editing on this graph. Double click on the chart, and then in this new window I'm going to double click on the background here to change it from gray to white. A new window will appear. I'm going to select the fill of white and the border also make it white. Click apply and then close. So we have the chart now in this presentation. I'm going to increase the strength and the color of the y-axis by clicking on this axis, and I'm going to use the line, and I'm going to increase the width into 2 and click on apply, and I'm going to do the same with the x-axis, increasing the width into 2, apply, close, and going to change the color of the circles here and the size of these circles by decreasing the size to 3 and filling it with dark blue and also darker blue here, and click on apply, and the colors of these circles is changed to blue. To insert a regression line, click on elements, scroll to fit line at total, and a regression line is generated with a equation or formula, regression equation or regression formula. And I'm going to change the color of the line by double clicking on the line itself, and then choose a red color and choose the width into 2, and then click on apply and then close. And I'm going to move this a little bit here up to here. This is the R square, and I'm going also to do a few changes here by clicking on the values for hours, and I'm going to make the scales, since the maximum number of hours is 15, so I'm going to type 15 and then apply. And also I'm going to double click on this line, and I'm going to lower the margin to 0, click on apply. So now we have here the regression line with the scatter plot. So from this scatter plot or regression line, it is clear that the relationship between both hours and marks are linear, and a regression formula has been generated, which is y equal to 51.01 plus 3.6 1 multiplied by x. If we go back again to this here, this formula or equation, it's clear that the y represent the outcome and b intercept, which is the value of y when x equals 0, and the b1 is the gradient or the slope, and the x is the predictor. So from this graph and this regression formula, it is possible to predict an outcome based on a value for x. So if we have a student who studied for 5.5 hours, then it is possible to predict the score or the mark that he will achieve in the exam using the formula generated by the graph. In this case, going to type 51 for the intercept, y equal 51 plus, the slope is 3.6. Put the sign for multiplication, x will be 5.5 hours. And if we're going to use a calculator here, so I'm going to look for calculator and use a calculator. In the calculator, I'm going to type 3.6 multiplied by 5.5 equal, then add to that 51, and that will be equivalent to 71. So that person will achieve a 71% mark in the exam if he only studied for 5.5 hours. So this 71% is based on the equation and on the graph here and on the regression line that has been generated for this set of data. So this is the way to draw a regression line in SPSS by drawing a scatter plot, then fitting a regression line that best fit the data, and then from that generate a regression equation or formula, and that regression equation or formula can be used for predicting an outcome.